Hello everyone, I am Balam Nandini. I have done this project as a part of my Embedded Systems Internship at EMERTXE Pvt, where I got the opportunity to learn and work on real-time embedded system applications. This project is based on automating the basic functions of a washing machine such as washing, rinsing and spinning using a microcontroller and various electronic components. It helped me to understand how embedded systems are used in household applications and how software and hardware work together in a real-time applications. Here is the table of contents. I will be explaining the project in steps, starting from the introduction, followed by the basic concepts like C and embedded C, the tools and the components used, the working of the system, and finally the conclusion. Introduction. A washing machine is a very common home appliance used to wash clothes. It saves time and reduces manual effort. The goal of this project is to create a simple, low-cost working model of a washing machine using a PIC microcontroller. The PIC16F877A microcontroller is used to control the various stages such as washing, rinsing and spinning using input from switches and output to relays and motors. C programming. C is a general purpose high level programming language developed in the 1970s. It is widely used for system programming, application development and compiler design. C provides low-level memory access, fast execution and portability, making it ideal for programming hardware interfaces. It is the foundation for many modern languages like C++, Java and Python. Key features of C. It is a procedural language. It is efficient and fast. It uses functions, loops, arrays and pointers. It is hardware independent. It is commonly used in desktop software. And what is embedded C programming? It is an extension of C specifically designed for programming embedded systems like microcontrollers. It includes additional libraries, macros, and hardware specific features that allow direct interaction with registers, input-output ports, timers, etc. It is used to control devices like washing machines, microwave ovens, traffic lights, and automotive systems. Key features of embedded C programming are: it works closely with hardware, it supports real-time constraints, it is often used with microcontrollers like PIC, AVR, R, and 8051. It uses bit-level operations and memory mapped input-outputs. It requires understanding of the hardware architecture. Coming to the what is the difference between C programming and embedded C. C is a general purpose programming language used for developing applications on computers, while embedded C is used to program microcontrollers and embedded systems. C programs run in an operating system environment like Windows, Linux, but embedded C runs on bare metal hardware without an OS. C has limited or no direct hardware access, while embedded C allows direct control of hardware components like ports, timers and memory. C uses standard libraries, while embedded C uses hardware specific libraries and registers. Examples of C language are calculator app, file transfer programs, and for embedded C are blinking LED and motor controlling washing machine. What is an embedded system? An embedded system is a combination of hardware and software designed to perform a specific task. It can be said as a dedicated computer system has been developed for a particular reason, but it is not our traditional computer system or general purpose computers. These are the embedded systems that may work independently or attached to a larger system to work on specific functions. These embedded systems work without human intervention. Coming to the components of embedded systems, there are three components of embedded systems. They are hardware, software and firmware. Digital watches, washing machine, toys, televisions and digital phones. These are the few examples of embedded system. And coming to the applications of embedded systems, there are few applications are there. They are home appliances, transportation, healthcare, business sector and offices and defense sector. These are the few applications of an embedded system. Characteristics of an embedded system: performs specific task, that is, embedded systems perform some specific function or specific tasks. Low cost, the price of an embedded system is not expensive. Time specific, it performs the task within a certain time frame. Low power, embedded systems do not require much power to operate. High efficiency, the efficiency level of embedded system is so high. Minimal user interface, these systems require less user interface and are easy to use. Less human intervention. These are the few characteristics of an embedded system. Next, coming to the purpose of this project. The main purpose of this project is to design a washing machine model that can automatically handle washing, rinsing and drying using a microcontroller. This helps to reduce manual work, shows how washing machine work internally and teaches how to control hardware using embedded C. Next, coming to the development tools used. The development of this project involved both hardware and software tools. Coming to the hardware tools, these are the physical components used to build and simulate the washing machine model. PIC16F877A microcontroller. This is the main microcontroller that manages all operations like washing, rinsing and spinning. 16x4 CLCD display. It is used to show the current status. Then dip switch or push buttons, which are used to select wash modes manually. Fans acts as a simulation of the spinning motor and in the washing machine, controlled by the microcontroller via a relay. Buzzer, used to indicate alerts like cycle, completion or errors. Use an audible sound when turned on by the microcontrollers. Then there are three software tools are used for developing this project. They are MPLAB X IDE, XC8 compiler and PICSimLab. MPLAB X IDE is an integrated development environment made by the microchip technology. It is used to write, edit, compile and debug programs for microcontrollers. It supports multiple compilers including XC8, XC16 and XC32. It offers features like program project management, simulation and debugging tools for embedded development. XC8 compiler. The XC8 compiler is a C compiler for 8-bit microcontrollers. It translates C or embedded C code into machine code that the microcontroller can execute. It is used within MPLAB X IDE to build and generate the hex file for programming PIC microcontrollers. It supports standard and extended modes and optimized code for performance and size. Then coming to the PICSimLab. PICSimLab is a virtual laboratory simulator for PIC microcontrollers. It allows users to simulate real-time embedded systems using virtual hardware like LCDs, motors, switches. You can test and debug your program without using real hardware. It is helpful for students and beginners to practice PIC programming with ease. This is the main controller used in our project. PIC16F877A microcontroller is the main controller, and it is an 8-bit microcontroller with 33 input-output pins, flash memory, RAM and timers. It supports communication, analog to digital converter, timers and PWM, and is widely used in embedded applications like this washing machine. It operates at a clock speed up to 20 MHz using a crystal oscillator. It is compatible with MPLAB X IDE and XCI compiler for programming in embedded C. It is easy to interface with LCDs, buzzers, sensors, motors and switches. This is the block diagram of our project. The microcontroller takes the input from switches and the outputs are connected to the microcontrollers. That is, the microcontroller takes input from the switches, controls the motor and buzzer and displays the information on the LCD. Components are used for this project are CLCDs, tactile switches, fans, keypads, buzzer. Coming to the CLCD, CLCD is a type of liquid crystal display used to show alphanumeric characters such as letters, numbers and basic symbols. The most commonly used module is 16x2 LCD, which can display 16 characters per line on 2 lines. CLCDs are widely used in embedded systems for developing messages, for displaying messages and system status in real time. These displays are controlled by the microcontrollers like PICSimLab using specific data and control signals. Tactile switches. Tactile switches are small push button components used to give digital input signals to the microcontroller. They work on a press and release mechanism and are commonly used for actions like start, stop or reset in embedded projects. In the washing machine project, tactile switches allows users to manually control or trigger specific functions. And buzzer. A buzzer is an electronic component that produces a sound when an electric signal is applied. It is used in the washing machine project to notify the user when the wash cycle is complete or if an error occurs. The buzzer is connected to the microcontroller and turned on or off through program logic. Timers. Timers are internal modules of a microcontroller like the PIC16F877A that are used to measure time intervals or generate time delays. In an embedded system, timers are essential for performing operations based on time, such as running a motor for 10 seconds or delaying an action by a fixed amount of time. In the washing machine project, timers helps to control the duration of each cycle, such as washing for a few minutes, rinsing for a fixed period, and spinning for a set of time. Keypad is a collection of multiple switches arranged in a matrix format like 3x3 or 4x4. It is used when multiple inputs are needed, such as selecting different washing modes, entering a time delay, or choosing a custom cycle. It reduces the number of input-output pins used by connecting switches in rows and columns. Fan. A fan is used to simulate the drum of a washing machine during the spin cycle. It represents the part of the machine that rotates the cloths to remove excess of water. The fan is controlled through a relay by the controller based on the selected wash cycle. In the demonstration, you will see how the system runs each step, that is washing, rinsing and spinning based on inputs, and how the LCD shows the current operation. The fan spins and the buzzer sounds after the cycle ends.
This is the MPLAB. I created a new project for washing machine. I wrote the program for the washing machine project using Embedded Systems. The program includes the logic for reading input from switches, controlling the washing, rinsing and spinning stages, displaying messages on the LCD, and activating the fan and buzzer using output pins. And this is the program for the washing machine project. To run the program, click on Build Main Project. If the code has no errors, it shows us build successful and it generates .hex file. And this is the PICSimLab. Here I load the hex file and I selected board is Exenius and microcontroller is PIC16F877A microcontroller and clock frequency is 20 MHz. LCD is 16x4 and I reload the .hex file that was generated from the MPLAB. To power on the washing machine, press on P5. Now it shows washing program screen. In washing program screen, there are few washing program operations also. First one is daily, then heavy, delicate, wide, stain wash, eco cotton, lens, bed sheet, rinse plus dry, dry only, wash only, and aqua store. Here I am choosing delicate as washing program. We have to long press on the switch 4. Then it enters into the water level screen. In water level screen, there are 5 water level operations are there. First one is auto, second is low, third is medium, fourth is high, and fifth is max. Here I am clicking on auto operation. We have to long press on the switch 4. Then to start the program, press switch 5 and it gives program delegate and the time is 26 seconds. We observe that the program is run. During the program, fan is rotating. Suppose the door is open. The door is open and it displays door is open. Please close the door. And in this display there are other two options are there. One is pause and another is start. If we want to pause the running operation, click on 56. Let's get click on 56. We observe that the program is stopped and fan is not rotating. To continue the program, click on 55. Then it starts. That is program is start. We observe that the function of the program is changes from range to pin. Once the program is completed, buzzer will sound for 3 seconds and displays the message program completed remains last. Now we can back to the washing program screen. If we want to stop the program, let's click on the delegate. We have to long press on the switch 4 button to select washing program delegate. Then we enter into the next system, that is water level scene, and here I am selecting water. If we want to stop the program, press on switch 5. Then we observe that the program stop and we can back to the washing program screen.
This project successfully demonstrates how a washing machine can be controlled using a PIC microcontroller. The system responds to user input, runs each operation for a fixed time, and displays the current status clearly on the LCD. Through this project, we learned how embedded systems are used in real-life appliances and how to interface various hardware components using Embedded C. It also helped us understand the importance of automation, timing control, and hardware-software integration in electronic systems.